Hi everyone, welcome to the video. Today we are going to solve a hard question, but which is pretty good question. We are going to solve distribute candies in a binary tree. So we are given a binary tree in which each node has some value. Some may have some value or may not have some values. The value represents the number of candies, and we have to do some operations. And after that, each node should have one candy. We have to distribute the candies. So as you can see in example one, we have the root as 3 and the left and right subchild having value 0, but we have to distribute candy so that everyone has one candy. So we will do some operation and give one out of these 3 of the root to the left subchild, and similarly we will give one out of the remaining 2 of the 2 candies from the root to the right subchild. And we in total we did 2 operations, hence we return 2. So here we distributed from parent to child, but this operation can be vice versa. I mean, child can also distribute or give to parent. We will see in example 2. So here root is having 0 candies, right subtree, right child is having 0 candy, but left child has what value 3 candies. So it will give all the candies to the root, as I mentioned some seconds ago, that this operation of distributing candies from both from parent to child and from child to parent in both directions. Cool. Now we gave candies from left child to uh, root. Then root distributes one candy each to left and right. Afterwards, which cost 3 operations. First, this child will give all the candies to root, then will root, that would have been one operation. Then root will give one candy to left, root will give one candy to right. In total 3 operations, and hence our result is 3. Okay, so to begin with this question, I will obviously solve this question using recursion. First of all, I will create a constructor with the value result, because we will be using this value time and again. So I'll declare it as a global variable in this function. I will say in class variable, not global variable. Okay. Now I'll create a helper function or utility function. You may call it whatever you want to. With the value node. Okay. But what will I pass it? I will pass, as you may have guessed, root. And at the end, I will return this result, this class variable which I declared moments ago. Now we will do some operation. But first condition, the backbone of every recursive solution is a base condition. So here, what is the base condition? As in most of the cases, most of the questions, when we frame recursive solution when it comes to trees, the most of the time, or I will say almost all the time, the base condition goes. One of the base condition goes if not node. If node is none, if root is none, in that case we will return 0, because we have nothing to return. When we don't have even root, there's no case that it will have left child or right child. There's no case of having candies to distribute. I mean, there are nobody to distribute, nobody to have candies. Cool. Now I will create two variables which will the left count and right count. Left count will distribute the number of moves to make for the what left subtree, and r count, right count, for the number of moves to be made to distribute candies for the right subtree. And in left I will pass node dot left, and in r count, right count, I will pass node dot right. Right, data left. Cool. Now I will here store or will update the result variable with the okay, what I did. Okay, sorry. So now I will store the update the result variable with the number of candies, number of moves to distribute candies for the current node, for the given current node, which will be absolute of left count and right count. I'm using absolute because it will yield us, if not using absolute, it will yield us negative value. What if we are not making any move? In that case, it will, for the left child or right child, it will yield us negative values. Okay. And also it may have the condition that we are not making any move from left subtree to right left to root and root to left. Okay, and at the end I will just return this left count plus right count plus node dot data. This is pretty this is pretty good because and minus one because we do not want to include this thing twice. We do not want a condition that the current node got included twice. Okay, and every node should have only one candy. And this was the condition wherein I fault this absolute. Initially, I failed because I was not using absolute. I was not able to figure out that this may happen. There will be no operations, and then I was not doing minus one, and it was giving me extra result. Okay, so because it included not twice the current node. So let me submit it for you and see how it goes. Yeah, it took pretty less time. It took pretty less time and it solved our question. So as you can see, my accuracy is 50% for initial so many attempts. I was not able to figure out the correct way because as I mentioned, I was, missing some edge conditions. But right now I explained this hard question to you in a pretty decent manner. And yeah, this question is classified as a hard question here. It's not that hard, but yeah, it's the edge condition are pretty critical to understand. So I hope you enjoyed it, the video. Thank you. Have a nice day.